So let us start with k-means. So k-means is an algorithm that is used for clustering data. You understand that unsupervised machine learning, we don't give labels to data, unlike what we were doing yesterday, whereby um, we were giving our data some labels. So in unsupervised machine learning, we just passing the data to the algorithm, to the model, and what model will do will its work will be now to like derive some patterns from that data, and after deriving some patterns from the data, cluster it will cluster the data based on similar features, or rather maybe group the data based on features. So data points with similar features will be grouped together. So k-means algorithm will just enable us to to cluster data based on their features. So that is what I want us to implement today, and I'll just check just two examples of k-means. Um, then we can call it a day. So let us just check the algorithm of this is the step by step of how to implement this k-means, and we're just going to start by initializing the k-mean with random values. You'll see how we do that. Um, and then we're just going to iterate through all the items of those generated random values. Um, the other thing that we're going to do will be to find the mean closest to the item by calculating the Euclid distance of the item with each of the mean. You guys, you understand what is Euclid Euclid distance of the item with uh, or rather the Euclid distance. You I understand you guys know will understand what is Euclid distance. In this case, we are just trying to calculate the distance of the item compared to that of the mean. Then we just assign the item to the mean, and then we are going to update mean by shifting it to average of the items in the cluster. So those are some of the operations that we are going to do to achieve our k-mean algorithm. So as we did yesterday, so the first thing is always to import relevant libraries, and we are going to use NumPy again because here we're working with arrays. We're also going to work with matplotlib. Okay, you guys, you can just open a new notebook. If you're using Colab, you can just call it k-means algorithm. I think I should also try to edit this. You can just call it Uh, yeah, K means I think algorithm makes sense. You can give it a name of your choice. So let us just start by importing these libraries. We import NumPy as NP, we import matplotlib.pyplot as PLT. And then from sklearn dataset, I want us to import these make underscore blobs. This will help us to create a custom dataset instead of instead of like having import a dataset from external sources. We can create our own using these make underscore blobs. Um, so I'm hoping that you're moving together. I think also from your end you should be writing some codes uh, so that in case you're stuck, we can help you. So you can just start by importing those libraries, hoping that my screen is visible from your side. So in my case, I can just run this to import those libraries. So the next thing will be our X input and the output. The output will be represented by Y, while the X will be our inputs. So how we generate those random samples? It's very simple. You just make blob, use the make blob function, and then you're just going to pass some attributes here or some parameters in this function. So the first parameter will be the number of samples that we want. In this case, we want just 500. We just need 500 samples. Let me allow someone to I think someone help me with that. So in this case, we just need 500 samples, and we just need n features. You can also pass centers. Uh, just just need 3 centers here, and the random underscore state. All these all these attributes of these or parameters of this function. So you can always modify them so that they can maybe fit your case. But in this case, we just need a data set of 5 with n samples. We just need 2 features, centers to be 3, and random state of 23. So I think we can just try to plot this and see this. In here, I'm just doing what the plt dot figure. In this case, I don't want to do what I'm just passing the 0. Do you understand that I don't want to put the size because this is not quite a large data here. Uh, so I want to plt.grid. So those data points will be in a grid, and I'm just doing the plotting here. You understand that this one is a scatter plot, and then I just show that. I think I can just run this so that you can see the actual output here. You understand that I have three centers of this data. Uh, it's only that we cannot count, but these are exactly like 500 data points. I think if you can count. You can just try to count and confirm, but that will take a lot of your time. But these are 500 data points, which are just divided into three three clusters. I'm hoping that we are together up to that point. Is there any question up to that point? And if you are getting an error, you can just maybe ask. Just to ensure that we are together. Is everybody able to create these data points? Uh, any person who have managed to do that?
Hey, please show your screen. I'm copying. I'm copying the.
Okay. Let me just 1 minute to copy this. Yeah, I think you guys should by now you should have copied this. Just around, is it 5 lines of code? Who is Drew? Who has managed to plot? Bedel is Drew. What about the others? Okay, apart from Bedwell, who was finished, who was managed to plot that? And are you able to plot that? What about Brianna? Brianna? Okay. I think we can just move on to the next thing. So after plotting that, I just want us to initialize the random set traits, and and that should be three. I think I'll explain these the code below here. So the main purpose of this code that I'm about to show you is that we're going to initialize the random centroids. Also, the code initializes three clusters for the k-mean clustering. Um, we will also set up a random seed and also generate random cluster centers within the specified range. I think I think we're going just to set up the number of clusters that we want as k. Just need three number of clusters, and even we initialize an empty dictionary here that will hold all the sets of random seed um, together with the centers. We can have our np dot random, and then we just set up a seed of 2023. You decide that np has that random as that as that random dot seed function, which will enable us to set a random seed of 23 in this case. Um, then you are going to iterate. I think we're going to iterate through the items, and while iterating, we just want to find the mean the mean closest to the item by calculating the Euclid distance of items uh, with each of the means. That is basically what we are just trying to do here. So the first thing, we just use the for loop to iterate, um, and then we're just going to set our centers. Centers is equals to 2 we multiply by that is in we open a parenthesis. We just need to take again a 2 we multiply by the our np dot random. And you notice that I'm using a random twice here, so that I can generate random cluster centers. So it is np. This is the syntax. You just have to take 2 you multiply by np, and then a random dot random, and then we are just going to pass in our x dot shape, which we are giving it a value of 1. Then we just want to to generate those random, they're called the random cluster centers up to the last up to the last up to the last data point. That is why again I'm using the minus 1 here. Um, those points I want them to be in a list. And that's why again I'm initializing an empty list here. Uh, and then you notice it initialized an empty what? An empty dictionary here. We said that this one will again hold all our what? We said it will hold all the sets of random seeds and the cluster centers. So in here, in this cluster, you notice that I'm setting now my center. Yeah, I just want the center, and I want the points. You notice you notice in here that after now iterating all these values here, whereby I'm taking IDX in the range of k representing my data points in this case, and then just uh, having the center value. This code here will this formula here will generate my center here, and that center is the center that I'm just trying to put here. I just need these clusters to be in form of a dictionary, and you notice that I'm using a key and a value key and value uh, as I must have the center as key, and I want the value of that center. Uh, in this cluster, you notice I'm also using the point. You notice the point here. I did set them as an empty list. So each and every point here will be set into these these empty empty list here. So my cluster will be of this nature. That is the value of the center and the points. So I think we can just run this and see the nature of output. I think the nature of output will somehow make make sense. So you understand I have zero, that is zero to one centers, and these are my now these are just the clusters. The cluster has its center, which has its value as these ones, and in this case as the points are just empty at this instance. So again, I have that is one center. It has these values, that is the array, and also it will initially it will have 0 points, and the that. Notice that these are just basically what are these are my clusters at this moment, and those are that this is basically what is represented by this visualization here. Just my data, that is my centers, that is 0 to 2, and having their points as these ones. Um, we can just try to plot the random in random. We can just try to plot the random points with now data points, whereby I'll just have to create this code here that will enable me to plot my graph now with some data. And you notice that in here I'm just trying to draw again another scatter, and I also need this one to be in grid, and then I'll just look through the clusters. In this case now my center, you notice that uh, I'm equating these two to to some value here. That is the clusters. You notice that we had clusters here. That is what I'm trying to look through, and assigning some values. So that is will be center is equals to clusters, and that that is, these I just represent any value in that dictionary, and I that any value in that dictionary, and I also want the the, the list of the center. So it will now be value or all the values in this cluster and their centers. So let us just try to plot these and just try to see the output here. You notice that I have or something I just left there. You notice that I have some red marker here, and this red mark here will enable us to you notice after we have this red mark here, it will just help us to like just like label our clusters. You will see that after we have passed this data through the model, you'll notice that each red dot will be somewhere in the cluster. That is why we are saying the plot displays a scatter plot of data points uh, with grid lines, and it also marks the initial cluster centers. That is the red stars. These are our initial cluster centers at the moment. But after now we have this one is before we even pass our data into the model. So we just have the initial clusters as these ones. Let us just try to define the Euclidean distance of each cluster, and we are going to achieve that by just this function here, whereby we are just passing two arguments, that is p1 and p2, and this one will just return. We have a formula of achieving the Euclidean distance. I think I'm not quite well equipped with the statistical what formulas, but I understand this is the formula for calculating this Euclid distance here. So I just have my this is just a function that will return the Euclid distance for each cluster, and I just wanted to return np dot. Now I understand from here this is the formula for calculating this Euclid distance. Uh, I really remember these formulas, but I'm hoping this will calculate the distance. The statisticians can just confirm that, because this is basically what you do in in clustering, well, in statistics. So this is just we are just trying to use now the algorithms just to to achieve what you guys do. I don't know how you achieve that in statistics, but what I'm trying to do is just an implementation of uh, calculation of this Euclid distance now using Python. I don't know whether this is the formula, but you guys you can just confirm this before even we run this. Can someone confirm? Is this the formula for calculating the Euclid distance? I think someone can confirm. So someone to confirm? Is this how we calculate the Euclid distance in statistics? So someone can just confirm. Who is doing a statistic course? I understand that Anne is doing statistics. And is that the formula for calculating the Euclidean um, distance? I think let us just hope it is the formula. You guys will confirm later. I'll also confirm. Um, but this is basically the simple function for doing that. You notice that I'm just passing two arguments, that is p1 and p2, and in here you notice that in my return function here, I'm just like calculating now the square root of that is np dot sum. Understand, we are doing what? We're just taking the value of p1 minus p2 and then squaring that for each and every cluster point, and doing the summation, and then finding the square root of that. I'm hoping that this is the right formula, but of course I don't think these documentaries can give a wrong formula. Um, so after having that function to calculate the Euclidean distance, we now need to create a function to assign and update the cluster centers. Um, you notice that these are our initial cluster centers. So update, we need to update this, since now we have calculated we have the, we have now calculated the Euclidean distance that is between our initial cluster centers and our data points. So what we just need is now to create a function that will assign and update our cluster centers. And this we are just calling an e-step. Uh, the e-step will assign data points to the nearest cluster centers, and you're just going to see that in a bit. And we are told that the M step updates the cluster centers based on the mean of assigned point in K means clustering. So let us begin by each step that will assign data points to the data points to the nearest cluster centers. I think you're just going to run this code. This is the implementation of that. I think I don't have to explain this kind of code. It's just a function that will enable us to update um, that will help us to assign data points to the nearest cluster centers. And you understand that these are our cluster centers. That is these red these red these red dots. So in a way, we are just trying to assign these data points based on the distance between this data point and these cluster centers. Uh, so that is based on the distance. You notice that these data points here, they can't be assigned to this star here. They must be assigned to the star that is closest uh, to this data point. So let us see that in action. This is just the function to do that. You can just run these. Yeah, I think that has run successfully. So let us just move to the M step. The M step will now update the cluster centers based on the mean of assigned point, and then we plot that. We see the output for that. We can also run this prediction here. And in here, let me just explain this. So this is just to assign and update and predict the cluster center. And the code before this, we were just trying to create a function to predict the, the cluster for each data point. So this is the function that will enable us to predict. And by predicting, I just mean, okay, if now we are at this point, how do we tell that, how will these k-means algorithm now, like, people to know that these data points are the ones that are closest to this star, and how also do we tell that these data points are the ones that are closest to this star and not this star? So how do we do that? So that is what we are basically like doing here. We just have to create a function to predict the cluster for the data points. And even like just knowing, okay, which data points should be in a certain cluster again. So that is basically the function, the purpose of this function, just to create a function to predict the cluster for each data point. And you notice I'm just doing that by passing in our x values, that the ones that we generated here using using our make probes here. You notice that I say that the x will be our input. So that is what we are just trying to pass in the predict cluster. Just passing that data, and then we are going now to pass the clusters. You understand that we created clusters. I think only three. We defined three clusters here. Um, we defined k as our as our as our number of clusters that we're going to have. And I said that in these clusters dictionary, this is where we are going to hold all the sets of random cluster centers and their data points. So that is what I'm basically like now just trying to pass in here, the points and the clusters, so that now this data be will be grouped into these clusters. So the initial prediction will be an empty list, and then I again iterate through all the data points in X. After that, you notice that I am initializing the distance, the distance into an empty list again, uh, so that all the distance that will now be calculated, that is the distance between, that is the cluster centers and data points, will be held by this variable here. We are doing just an append, whereby I just want now to append all the distance between the X point and cluster centers. I just want to append those values. That is the distance between the clusters and our data points. You notice that I'm using X and then I just to represent all the points in X. So in a way, we are just going to calculate the distance between the cluster center and our data point. So that is what those are the values that I'm appending to my list here. So this dist is just a short form for distance, but it will be the distance difference between, that is, data points and and our and our cluster center. After that, you notice that I just want to, in my prediction, I just need the mean. Okay, how do I tell that? Okay, let me just try to explain with these. So I just want the minimum, the mean distances. So that is if the cluster point is around here, and let's just assume that this is my data point. It's just here. So you notice the distance between this point and I'm assuming that this is my cluster point, I mean the cluster center. I just need the to assign uh, to assign to assign a certain data point to to a certain cluster. I just need the minimum, the mean distance between the that is the cluster center and the data point. And after appending all these values here, I need again now to calculate the in my prediction. I just this is to my pred. You notice that it was an empty list here. So I want to append. I just want to append now based on the distance. That is why I'm using the np dot argmin. This is a function that is used to calculate the mean distance, the mean distance between 2 points. In this case, that is the distance between my X data points and cluster centers. So that is what I want to append into this list. And then in this case, because it was a prediction, it was a prediction function, I just want to return to return all the values that will be now in this list. So that is basically what this function is trying to do. After that, I'll need now to update. That is to update my new clusters, and this is quite simple because I'm just trying to do what I have these clusters. I want to assign those classes to the new values of that is X and clusters. That is basically what is just is that is what is happening around this cell. Um, After doing the update, I just want now to plot the data points with the predicted cluster centers. So again, I'll just make use of scatter plot. You understand that I'm now trying to look through all the clusters, um, trying to assign some values to, I mean, some data points to them. Um, I'm going to use a marker here in this plot, just, just with the center. Um, these are just the attributes for these scatter plot. Um, in here, I'll just pass the mark that is red, and you notice this mark is around somewhere at the center of each and every cluster, to mark the cluster center for the for all these data points. So that is basically that with the k-means. It's just it's just trying to cluster data based on their characteristics, and even going further to indicate the cluster center for each cluster, like in this case. Um, any question regarding this? So even we are already here, the plot shows the point colored by the predicted cluster. The red marker represents the updated cluster center after the M step in the k-mean cluster algorithm. So I think that is basically that with the k-means algorithm. Um, I don't know if there is any question regarding these code snippets. If you have any question, you can feel free to ask before we get into the other example of k-means. Today I said I don't have much to discuss. Um, so any question or any person who feels that we should maybe repeat something in this example, or any person who feels that he or she needs clarification on this. You will just have to take your time to go through this, to go through this through these codes, because again they are not quite straight, so you will always have to go through them so that you can at least understand what is going on with these algorithms. There are so many. So I think from our algorithm here, or the step-by-step approach, I think we have covered everything. We have checked on how to initialize the k-means with random values using these make blobs. You have seen how to iterate through those items. You find the mean closest to the item by calculating the Euclid distance of the item with each of the means. And even we have tried to assign item to mean and even update by shifting it to the average items in the cluster. So this is the step-by-step approach of that algorithm. Um, any question? I'm waiting for any question before we get into the other algorithm. Any question? Uh, I think if no question, we can move to the next example. Um, and in this case, I'll just try to use iris dataset. I'll use the iris dataset here. In this case, I won't like generate my own dataset. I'll use iris dataset, and we can start that by importing these libraries. Um, you can import pandas, import numpy, synbone, matplotlib, uh, and that is matplotlib, cm, and cm. Thank you guys. You can let me just share with you these imports, so you don't take much time in typing these imports. You can find these in your in call messages. You can just copy paste that. And the next step will be to load our data set. And yes, it's just the same as what we did in the last example, whereby we have our x's inputs and y will be our output. Um, so then we are going to load these IDs. It's quite simple. We are loading these IDs from the Skylab datasets. You notice that there is somewhere we have imported these from sklearn.datasets. We have so many datasets in these sklearn.datasets module here, and load underscore iris is one of the examples of the datasets that we have in here. So I'll just run these to import those. And, let me just try to admit someone here. yeah, you can load this data. You just have to you can have just these two variables here, that is capital X and Y, and then diaries, and then you can just return X underscore Y to true. Is the easiest way to load these data sets, especially the ones that are in these scalar data sets. Oh, so the next thing that you're going to do is finding the ideal number of groups to divide the data into to what to divide the data. I think I had a typo here. I should be finding the ideal number of groups to divide the data set into. Yeah, the data set into in my unsupervised. Yeah, I think that now should make sense. So in this data set, I just want to check the ideal number of groups that I can divide this data set. You understand that in the last algorithm, we, we just we just had coded that we need to divide that data set into three. But there is a way. There is a way you can check the, because in most cases you're just going to be given a data set, and even you don't know the number of times you want to cluster that data into. So there is a way. We call it we plot it's called an elbow. We draw an elbow graph that will enable us to determine the ideal number of groups we can divide our data set. In this k-mean algorithm. I think we can just try to let us just see how we go about that. Um, and in here we're just going to use the k-mean. We have the k-mean. We have something we call the k-means. If it is that I have imported it here from the scalar cluster, I have imported this k-means. This one will enable us to check this. So let us just start by initializing the sum of squared error into an empty list. That is basically the meaning of this SSE. That is the sum of squared errors. You can just initialize it to an empty list. And then let us just look through. Let us just look through this. You notice that I'm giving. I'm just assuming that in this case, I'm just assuming that the ideal number is between 1 and 11. That is why I'm using these. I'm using these range function here by setting one, one and 11. Uh, So my loop will execute 11, no, 10 times, because it is always n minus 1. In case this is now 11 minus 1. So this loop will run 10 times, just trying to find the ideal number for grouping our data set. I think after now looping through that range, we can set our km on k means is equals to k means, and then we just set our n classes into whatever number that will be generated here. And then I'll use a random state of 2. After that, I'm hoping that you guys remember the feed yesterday in the linear regression. So in here, you're just trying to you understand that x holds our input, and we're just trying to do what? We're just trying to fit our model, that is the k-means model with this data here. That is basically what we're doing here. You remember what we said fitting is yesterday. So I'm just trying to fit this model with these x representing the value of inputs, all the inputs in the data sets. And then I'll just do what? I'll just append all the generated values here into I'll just store these into my SSE, that is the sum of squared error. And if I happen to run these, you notice that this is the kind of output I'm getting here. You can just count this to check that it has looped around 10 times. Just trying to check for the ideal value of k. It has just run through, it looped through 10 times. I think you can just count this. That is the sum of the squared errors. I think even you can just read through this and see that the default value of n underscore init will change from 10 to out in I think you should even this isn't quite relevant, but what you can just understand is when now you're setting this range, I just use a range of 1 to 1 to 11 in my case. So I can just try to plot the elbow graph to find the optimum number of clusters, and this elbow graph here is the one that will enable us to get the ideal value of k. So I think you can just try to plot this graph whereby I'll invoke the CNS, and we can set the style for the grid. I just need a white grid. What else should I pass here? So my Y data is SSE, and then you notice that I'm also including the range. The range is my x-axis here, that is 0 to 11. This is the range of 0 to 11. That is the number of clusters k. Um, After here, I'm just doing the usual operations, that is setting the x label, y label, and even the title for the graph. Um, by using the g dot set, you decide that I have g as my instance of SNS. That is why I'm using g dot set. I set my x label, y label, I set my title. I think you can see all those. That is elbow method. That is my title. Is my y label here will be sum of squared errors, and my y, that is my x-axis, number of k of clusters k. I have it as my what is my I have the number of cluster k being my x-axis. We are told that in this graph here, from the above graph, we observe that at k is equals to 2, and also k is equals to 3. You can notice that by uh, maybe I delete someone here. Where is this? It's just right here. We are getting our elbow here at this point. You notice this joint here. We just check at these joints, and in my case here the joint is at 2, and I have another joint somewhere around 3 here. So your value of k can be either 2 or 3. But in our case, you're going to use k is 3. I'll again use the k is 3. So you can have many number of these the cluster points. That's that. I mean joints rather. Like in this case, we just have two. But in case you find maybe more than two values, you can always choose the one that you think that can fit the case. But in this case, I just want to use three. Just need to use three clusters. Um, after just knowing after now knowing the um, the number of clusters that I'm going to use, I'll just have to use it here in my algorithm, that is k-means algorithm. And I notice that I'm setting my n clusters as 3. I want to cluster that data set into three times, and using a random state of 2. Um, I think after that I can fit my data now that I have um, now that I have now my model here having all the values, that is the n classes and the random state, n classes being 3 and the random state being 2. I think I can now take the value of these and store it in k-means here, and all the values that are going to be in this model here, we are going now to use them to fit. We are going to use the instance of this model to fit our we're going to fit the instance of this model with our x values. So how we do that, I'll just invoke the model. Now that our model uh, is stored in this variable name, and I'm going to invoke this function for fit and even pass my my x values, that is the input. So after doing that, I can check the class centers, and again I can achieve that using the k-means dot class underscore centers. So through this line of code, I'll achieve all all my cluster centers, and they are represented in the form of an array here. Um, so these are my cluster centers for this, and this is what is now going like to be used to to check the differences between all the distances, and I can use my what I can use my fit predict function in the k-means model to just try and predict the cluster groups. So with this, what I'll achieve with this k-means dot fit underscore predict will now group all my data points into three clusters And I think I can just run through this. I can just run through this code so that you can see my data set will now be grouped into three groups. That is the zero groups. I'll also have the one group, and I also have the two group. You notice that my data set has now been clustered into three clusters, as I indicated here. I think I can maybe change this one to two, and see what can happen here. And if I were to cluster my data into two, you notice that I now get zeros and zeros, zero cluster and one cluster. But because I think I'll show you the nature of these iris dataset, so that you can understand the reason why I'm clustering these into 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 three. Um, I think we can try and plot these cluster centers with their data points and see what will happen here. Um, let us just let us this code will just help us to plot these centers, and I'll also again use the red mark. um, let us just run through this, um, so that we can understand these. um, you notice in here I think we can start with this subplot here on the left that will display the petal length plus the petal width. And we'll have our data points colored by clusters. Um, we know that the red marker indicates the game is cluster center, as we had indicated in our code. And the subplot on the right shows the sepal length and the sepal width similarly. So we have the plot for at the left display showing the petals, and we have the this one on the right we have the sepal length. So this is data set is just a data set that contains information about flowers. It will indicate the petal length, the petal width, and other information about flowers. So that is basically what um, we can achieve by clustering our data set. So again, even the k-means clustering is powerful unsupervised machine learning algorithm for grouping and labeled data set. You notice that in our data here, we didn't label any data point, but we are just trying to use this algorithm to try and cluster our data points. Let me just try to run this. Let me run this so that I think I should have so that I can have three clusters. You should have noticed that you notice that now I have three clusters. That is the green, we have the blue, and the black clusters to represent each case. That is the zero case, the one case, and the twos case. Um, any question up to that point? Any question? I'm waiting for any question. Any question up to that point? I think with cluster is just like trying to you pass in a data set, and then your algorithm just tries to group that data based on their characteristics. And this one will be used in most cases. In most cases, it's used in cases where you need just to cluster some data into different groups. Um, so that is basically that. That is basically that with the k-means algorithm. And if you have any question, you can just ask. And I think someone has a question. And that is Wema Odiabo. Wema is asking, is anything going on? What do you mean by is anything going on? Any questions so far with this K-means? It's just quite easy how it operates. You just need like just to understand the basics of this algorithm. Um, you understand how to the libraries that you should use. You understand how to load your data set in a data set uh, that maybe you are required to cluster. Um, this part is optional. Like this part is just optional, just to like to find the ID value of k using the elb approach. Like you notice in the first case we just guessed. Uh, we just guessed the number of clusters that we need, but we guess if at all you know what you are trying to be, what what you are doing, or you have an understanding of the data set that you have. Like like I knew that I needed three classes in these IDs dataset. I think I can just check that in here. Let me IDs dataset. I think you can just have a view of we can have a view of that dataset whereby the, the, the flowers are divided into three. I think I should. And then let me just download these and we can have a look at it. Um, let me just unzip these. And these are some of the data sets that uh, you should check. Let me just try to open this file here. I can open that using the notepad. Yeah, this is the kind of the data set that I'm referring to. It's just like data is just information about information about flowers, whereby we have the petal length, we have the sepal length, you know, I mean the petal wing, the sepal wing, and then we based on those based on those values, we determine the type of the category under which that uh, flower lies. So we have the iris setosa, we have we have the vasous color, and we have another one that is called the iris virginica. So that is where you can see that that we have managed to cluster these. We have managed to cluster these into three parts. You notice that we have three types of the three types of the three types of the three types of flowers based on the petal length, and we have also based on the sepal length. So that is basically the use of these K-means. Um, I don't know if there is any question about these K-means. These K-means, and you guys, if you have any question about these K-means, I think it is the best time to ask. It is the best time to ask. If at all you don't understand anything, it is the best time to ask. Um, these algorithms are not always easy, and so you should not be surprised why most of us. So I think my mic muted, and you guys are not telling me that I'm speaking on a muted mic. Peter Kanjoi,
Yes.
yes, why didn't you guys communicate?
Oh,
At what instance did you guys lose me?
like 20 minutes ago.
20 minutes ago, I've been talking on a muted mic.
Oh, apologies for that.
You guys, I don't know. I don't know. Now, what should we do? Um, but I'm asking if there is any question on that. Is there any part that you guys you have not understood? I think you guys you should have communicated in the WhatsApp group. But anyway, it's okay. It's okay. It's okay. It's okay. I think. So if it is like 20 minutes ago, um, were you guys able to get or should I repeat the second example, because I don't know at what point you guys uh lost. So should I repeat on these example, or we are good? That goes to Peter Kanyo, Wema, Jonah, and David. Should we repeat that?
Yes,
Uh,
kindly.
okay, okay, okay. Um, okay. Let me just repeat this because of so that even it can be covered in the recording. Huh. So we were saying you just have to import the necessary libraries. That is, I think we had covered that. You load our data set, having our x as our input and y as the output, and we are just loading these IDs we just load in this iris dataset. It is available in this skyline dot datasets module here. So that is why we are not using the pd underscore dot pd dot read csv file because it is available in these skyline datasets.
Your screen is not shared.
Okay, let me just try to resume that. And I think uh, we should tell the others. Peter, can you take the others to rejoin? I think you can ask them to
Okay.
rejoin. Yeah, yeah,
Uh,
yeah. Um. So we have these. We are just going. I'm hoping that the screen is now visible. I think you guys you can confirm that. Are you able to see my screen?
Yeah.
Okay. Uh, so let us just begin by loading this data set. And how we do that is just load iris. And then you just want to return the values of x and y. That is why I'm setting this one to true. After loading the data set, what we need is now to just finding the ideal number of groups we are going to cluster our data set in this algorithm. You understand that it is an unsupervised algorithm. That is why we don't have data labels. Um, so and as I was saying that one way, well, one technique for just trying to figure out the ideal value to use in place of k, that is all the number of clusters, is an elbow. We call it elbow approach, whereby we just have to plot a graph, and in that graph you're going to check to check these joining. You're going to see that these these points, these joining points. We're just going to count them, and then maybe we can replace now the value of k with the value that we get there. So the first thing that I'm trying to do here is setting the SSE, that is the sum of squared errors, um, as an empty list, as an empty list, and then I'll just try to I'll use a range of 1 to 11, so that just trying to check the ideal value. That is why I'm using this loop. I don't want to loop through 10 times. You notice that it will be now, since I'm starting from 1, it will be 11 minus, we always have n minus 1. So meaning that uh, this loop will run like not like but 10 times. And I think you can just check that. uh, you notice that this loop has just run 10 times, just in pursuit of checking the ideal value of k. So after it has learned 10 times, we can just now try to plot this elbow graph to find the optimum number of clusters. So to plot that, um, I'll be able to draw that using this SNS or this library here. That is the Synbone library. By now, you guys you should have understood. You should know that CNS will help us to will help us to do what, to plot that. Um, so I just okay. The rest are quite obvious because what I'm just passing here is the y values, and you understand the y values. I'm assigning them to the variable of SSE, and that the SSE in this case was 10 times. Um, and the x values will be the range now between that is 1 to 11, which you understand again that it is around, is it 10 times. So after that, I'm just trying to label my graph whereby I have the x labels, the y labels, and even the title. That is quite straightforward. So from there, this is the after I run this, um, this is the kind of graph I'm getting, and you notice it resembles an elbow. That is why we call it elbow method or elbow technique of getting the ideal value for the number of clusters. So in here you're just going to check the joining point. You notice that this is a line and it has a joining point somewhere here. You have also another joining point around 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 here, and you notice that this one is around is just is at the middle of 2 and 4. So basically this one is 3 and we have this one is 2. Um, so in this case, because we are training our data set, we are just trying to cluster it into 3 times, and you know that by the kind of the, the the nature of our data here. We have three types of flowers. That is the iris setosa. We have the iris vascala, and we have the iris virginica. But you notice in this case there is no way we even like told our model that we are using these values as our labels. And like yesterday where we were choosing a certain column to be our label. I think yesterday I showed you how to specify a certain column as your label. Um, so in this case I just use a cluster of 3, and that is what I'm basically doing here. Just creating an instance of k-means algorithm. This is an instance of k-means algorithm. This is the k-means, and in this k-mean, this is where I'm just passing the number of clusters, and the random state is 2. Um, so I think now having set those values in having set those values in our I mean in our just a minute.
now do constant updates in terms of those who, in terms of students being able to revise and check here and there just to ensure that they ground the content that they receive during the program. So that is why we are also not interested in really lengthening too much, so that we don't really get to bore down some people. Some people have already started asking, and one of them, I don't know whether I should mention, and that was Yvonne, was one of them that asked, when are we ending? Yeah, so that's it. But I'm seeing James is back.
Yes, I'm
James,
back.
what's happening with your network?
Yes, I'm back. I think it's a power issue. I was trying to source some data. But I'm back now. Just to finish up. Where were we? I think I was at this instance where I was explaining the elbow method, right? And I was saying that elbow is one of the technique that is used to like to enable us just to like to get the ideal value for the cluster for the cluster number that you are going to have in a certain data set. So having drawn that graph here, you understand that now we have a data we have a graph we have a graph that resembles an elbow. So and that is why I'm saying that in the joining points you should just read the values. In this case we have 2, and also we have another value here that is in between, that is 2 and 4, so that is 3. So in here we are just going to consider using 3, because I think I already now showed the nature of the data set that we are trying to cluster. It has three categories, so I basically just want to use that 3, but also using 2 is not bad, but in this case let us just use 3, because you already know that our data set is divided into it has three categories of flowers. So after that I'll just create an instance of this game model.
Hello, James.
Yes.
Kindly share your screen.
Oh, you guys are not able to see my screen. Okay, let me just resume sharing. Um, Next time you guys you didn't tell me that I was talking on a muted mic. Yeah. What about now? Are you able to see my screen? I think you can just confirm that. Are you guys able to see my screen?
Yes.
Yeah. Okay. Thank you.
Yeah.
Oh, yeah. This is the graph that resembles an elbow, and this is how we check the number of clusters. You just check at the joining point in that graph. You notice that you have a straight line coming to this point, and then like this one is a joining point of this line and this line. Again, we have the joining point of this line and the other line. This one is it's a curve kind of, but you can see here we have we have a joint here. So we are just reading these points. That is 2 and a point between 2 and 4, that is 3. So in this case, I'm just saying that we are going to use 3 as a value, number of clusters. And After that, I'll just create an instance for, let me just indicate this. Let me just indicate this. This is that is the game model instance. Um, yeah, and in this game model instance, I'll just pass the number of clusters as 3 and random state of 2. So after that, I'll just use the my k means model here to fit it with some values. I think I'd explained that we have our x variable holding the values the values for input, or rather our input. Um, so after fitting that, I can just try to run these. Uh, we can just give it a minute to run. Yes, I think it has run successfully. So the next thing to do is now to find the cluster centers. So again, our game is modeling has a has a has a way of just finding the cluster centers. We're just going to invoke that game is model, and we have these dot this dot this cluster underscore centers. This one will we're just going to return an array with our cluster centers. So if I just try to rerun this, you notice that I'm going to get an array of values that are our cluster centers. These are the values that are going to be used to just to check the distance. You notice the last in the last example you were calculating the um you are there is a point that you are calculating where is this point that you are calculating the Euclidean distance at this point. But in this case now we have our k means just giving us the cluster centers after we have done fitting. The next step will now be to predict the cluster groups, and this will basically like now divide uh, whatever values that we have passed here. Now, based on these, the cluster centers, we'll just be taking a point and then minusing it from the 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 cluster. I mean the taking a point and minusing it from the cluster centers. So we'll just have to predict the cluster groups, and in this case, we expect since we passed an n cluster of 3 here, we expect that our data set will be divided into three parts. So, and I think you can basically see that we have the zeros cluster, we have the ones cluster, and also we have the twos cluster. So that is this shows that our model is quite working well with even its prediction. Only that there is an instance that we have. Let us check this. We have the number of continuous zeros up to this point. And then you notice there is an instance that in ones here we have some two, though not they are not many. But I think this just number of twos can't affect our clustering. but we have our data basically divided into predicted to that we are going to have 3 clusters here. After that, we can now plot. We can plot our cluster centers with the data points, and how we do that is through these kind of code here. Again, it's just a repetition of what we have been doing. By now, you should know that the PLT figure is just indicates the figure size, the subplot. You understand that this one will have, we are going to have two subplots in one row. In here we're just trying to do what? We're just trying to pass some attributes to the scatter function. You always know that you can indicate the values, you can indicate the data, even the C map. I think you guys you can from the previous lectures you by now know what kind of attribute we pass in this scatter plot. We also setting a grid to true so that our graphs can be our graph can be subdivided into grid format. Um, in here we're just trying to this for loop is just for just doing what we need a red marker in these clusters just to indicate the center of each cluster, and we are achieving that by this. You understand that we have different uh, we have 3 types of clusters, so we must loop through those cluster centers so that we can at least have a red what a red marker in each and every in each and every in each and every cluster. That is what we're trying to achieve through this loop. I think the rest you guys you understand is that we have the X label and the Y label, and this is the plot that will appear in our left, and now again we repeat the same process now to the graph that will appear, the subplot that will appear in our right. So after running these, um, we are getting we are getting 3 types of clusters in here. That is the green. We have sections where we have blues, and we have also sections that where we have where we have where we have we have blacks. That is on the petal wing. You notice despite the fact that we have clustered this data into three uh, into three into 3 times, you understand that uh, you understand that the blue data points and uh, the black data points, in a way there are some instances where they are overlapping, and this is read by so many factors. You notice that we didn't even clean this data set. We did carry out the EDA process. Um, that is basically something you can simply do on your own. Um, and that is the reason why we are getting some of these data points overlapping. But if you carry out the proper EDA process on iris data set, I'm sure you're going to get some clusters similar to this, you understand that this one was quite perfect. In fact, it was perfect. Um, I think that is basically that with the k-means algorithm. It's it's quite easy to implement this. In fact, it is the simplest kind of algorithm uh, to implement. Um, I think having checked those two examples, you guys should now be able to understand what k-means algorithm means. So, any question? Any question from these from this example and even the previous example? If you have a question, you can just you can ask. Also, if you need some clarification, you can still uh, request for that. Yeah, but basically that is the k-means algorithm. Quite easy to implement. If there is no question, you understand that we had divided machine learning into three categories. That is supervised, unsupervised, and reinforcement machine learning. So this k-means is an unsupervised machine learning algorithm. And yesterday we covered the linear regression algorithm that is for supervised machine learning. So what we are left with is the reinforcement machine learning, and I'm going to leave that for for your research. You're going to research on reinforcement learning and even try to implement some of the algorithms in reinforcement learning. Now that you have basic knowledge of these algorithms. Any question? I think I'm done with k-means algorithm. So you guys, you can just ask any question if you have any. I can see we are 15 minutes past our usual time, and I think Mr. Boniface had said that today marks the end of our training. That is on trainings on data analysis. There is Peter Kanyo who is asking, would you mind sharing the notebook file for reinforcement? Yes, I think I'll prepare that and share it with you with examples that you can at least understand. So today marks our uh, what our end of training session. That is all the sessions, the SQL, the Python, and the machine learning sessions. So this marks the end of our training. Maybe we can call it a wrap. It was quite long. Is it 5 or 6 weeks of training? But I'm thinking you guys have benefited from the training. Maybe I can hear some of the responses from you guys. So someone is asking of assignment submitted late. Yes. I think by Friday? No, by Saturday. For those guys who submitted their assignment late, you're going to get your scores by Saturday. By Saturday, you will have your scores with you. Uh, okay, can I have some responses from okay, I think because of time, I'll just need responses from two ladies and also responses from maybe two gentlemen, just to comment on our training sessions, just with a few words, and you can also share if you really benefited from our trainings. Um, so we are going to have Peter, that is Peter. Is it Peter Kanyoi? And you'll have Peter Kanyoi, and I think you can have David. And then we have Fahiza Adams and Wema. I think you can start with the ladies. Just comment out, and maybe you can even mention on what maybe you can improve on the trainings. So who goes first? I think you can start with the ladies. Start with Fahiza. Fahiza, we are waiting for you.
James,
Yes.
hello.
Yes, we can hear you, Fahiza.
This is not the Robert my network. I didn't get your question, so can someone
Okay, what we are doing?
else
Okay, we are just commenting on
help?
the training sessions, and maybe you can say what you benefited, maybe what you benefited from the sessions. You can also maybe give a suggestion if you have any on either of the maybe training. You understand that we had SQL trainings, we had Excel trainings, we had machine learning trainings, and even Python training. Maybe you can just comment on those trainings briefly. Okay, Wema, Faiza is saying we pass to Wema.
Okay. Hi, everyone, again. I would just like to say thank you so much. I have learned so much from the session since they began. I think I was so eager, one of those who was so eager when the classes were beginning. Yeah, and it's been 7 weeks that have gone down like so quickly. I can't believe we're coming to the end of it. I was already getting used to the shit. Yeah, but I've learned so much. Maybe what can be improved on, as you asked, is maybe how fast you upload the videos for those who have missed class, perhaps, because I normally see people asking for those videos. Maybe that can be improved on so that somebody follows up. You know, it's hard when this.
Yeah, sure.
I'm so grateful for the time, and I've learned a lot.
Okay. Okay, I think we'll check on that next time. That is, yeah, we'll check on that. And also, thank you very much for the kind, for the kind or the positive responses that you have given. That is in regards to our trainings. So I think we can go to Peter Kanyoi. If you can hear me, Peter Kanyoi.
Hello.
Yes.
Okay, so yeah, I'm audible now, I hope.
Yeah.
Yeah, so thanks a lot for the period that and for the effort and the dedication you Bounty Analytica has really invested. And as I've always commented, this platform is one of the few ones that you can invest and really see the worth of your investment. And so far it's been a good one. Beginning from advanced Excel, SQL, up to Python. If someone has been keen, following from your details notes, and if they have been also I've been following from YouTube and also from your notes and recordings. So I think it's a good way to kick off these programming languages. You read the notes, you follow the recordings, then you go for YouTube. Then you if you have time, you advance Kidogo. So it's been good. I'm loving the notes specifically for Python because there were so much details. But one thing I would like to raise about the codes for Python. I really found it hard to sometimes the examples that were being done in class. I didn't know whether they were not being saved or something, but I still felt that something was missing. So James, maybe I know you responded to it, but something small was missing because nikiona examples for then nikizikosa. So I think that's something you can check on. Also for the recordings, but you see sana because you have never failed to send. Now maybe you can incorporate by sending the marking schemes. In as much as kunakuwa na hizo division, but you can also incorporate the issue of sending the marking scheme. I think that would be great. But otherwise, the issue of timings for the class, participation and the resources and the notes and the codes, all those ones are very fine so far. That's why we always find ourselves coming back and over again. So if you improve on that, I think that would be great. Would be great for so that's for me. Yeah, and for us who tulikuwa tunasumbua sana group for the recordings because it schedule sometimes inakuwa iko fixed, but we appreciate that bit of recording the classes. Inakuwa ina save sana. Sometimes we got held up, but inakuwa iko sawa. So yeah.
Okay, that I think thank you, Peter. And I think also your concerns are also noted. I think next time in the next training, we're going to check on that. Any other person who feels that that he or she want to maybe say something as we conclude this training. Any person who feels that he or she want to maybe say something.
Thank you, James, for giving us the opportunity to comment and maybe a feedback or two. The training was well organized. A lot of examples were presented to us, and particularly the last bit of Python. You are very detailed and very orderly in the way the notes were presented. Very, very, very well. I was keenly following on that. The area that I thought, especially on the Python, can be improved is in what we are using as our notebooks. Either Google, you gave us options of Google Colab, Jupyter Notebook, and there were those who tried to use VS Code. And apparently, it appears that is what nearly ruined, especially the Python presentation, because it does appear that those applications were not working according to the expectations of a number of students. And we noticed that your end was working very well, but the impression that every other application could work, we call them ID.
Yes, ID.
Yeah, that the impression that every other could work as efficiently, it didn't seem to materialize. And I think if you noticed when a lot of questions in the beginning were asked in that regard, I probably noticed that's where the numbers went down. So I think maybe what you could do because you are so orderly in the way you had organized your presentation, I think right from the word go, you can harness the class towards Google Colab, because I've seen it is very easy, very light to make use of. So everybody, I think, should just be directed that way, so they are moving very efficiently, and people are not being frustrated by those other options. Otherwise, thank you so much. I mean, I've really been on the training every day, and I think especially the Python bit, the organization of your notes were very, very good.
Okay. So yeah, I think we are going to stick to what? To collab, yeah? It's only that I gave options. Yeah, but collab is always easy to use and also follow. I think we are going to stick to collab again in the upcoming trainings. But again, thank you, David, again for the positive comments, and also I think uh, you have been you have been like always like attending those classes, always on time. Yeah, I've also I did notice that there are some of the students that did follow, especially the Python classes. Um, you are among the students that really followed the Python session. Uh, Again, thank you for the positive comments. So I don't know if I'm leaving someone else who thinks maybe he or she has something to say. But again, um, the determined group will always have it. So again, I understand that you guys you are going to join our community. So I think Mr. Boniface will have a mention on that. That we have a community. I don't know if you guys you are part of the community, but if not, Mr. Boniface will work around that, maybe to make sure that everyone is now part of our community. Now that you guys you have gone through the trainings for data analysis. Um, so the graduation dates again, that is something that will be. I understand you guys you are forgetting. You always have graduations. So we will communicate that, and I understand that that will be communicated through the group. That is the group that we have. So again, if you have not done any of the assignment, kindly just have a look at it and even submit it, because that is the only way we can be able to assess that you really understood what we have been training. So again, just check all your assignments that are submitted, and if by Saturday you will have not maybe received your scores, you can always reach out to you can always reach out maybe to me or Boniface. I don't know what else I'm leaving behind, but I think I've mentioned like all the things that I feel that you should know. And again, I want to thank you again for having enrolled in our trainings. We thank you very much, and we are hoping that you are going to spread the good news to to other students, and even the for those who are from corporates, you're going also to spread that. Um, I think I've exhausted on what I was to say, but before we drop off, I think we have also trainings on digital marketing. You understand that that is the direction that uh, the world is moving to, digital marketing. So if again you would maybe like to join our trainings, maybe we will have the link posted in the group, maybe if at all you're interested to have our trainings on digital marketing. So having said that, I think I'll just wish you well. You just keep practicing on what you have learned. I think Boniface is on. I can just hand it over to Boniface, maybe to mention one thing or two. Over to you, Boniface.
Yeah. Thank you, James, and to everyone else who have been able to stick around up to the extra week. That is a testament of dedication from your side. It's only disappointing that today Nani did not attend. There's this lady called Sharon, one of the students that have been very consistent, including Wema, including Fahiza, Raban, and I believe like all of you, Yvonne is also there. You have been taken through a sprint, mostly, during the